Hello everybody and welcome to this video where we'll be talking about how to read skew-T diagrams. My name is Brian Verhoeven. I am a wildfire researcher at the Netherlands Institute for Public Safety and I coordinate the fire analysis team in the Netherlands. This video is composed of two parts. First of all, we'll be talking about the basics of the diagram, what's in the diagram and what do they mean. And secondly, we'll be talking about how to follow a rising parcel using a skew-T diagram. So let's begin with the basics of the diagram. On the right hand side of this slide, you can see a skew-T diagram. There's a lot of lines in there, but please do not worry as we'll be going through all of them and describe and explain their meaning. But to understand the diagram, it's better to first start to understand the name of the diagram. Officially, it's called a skew-T log-P diagram. That means that it's composed of two parts. The first part is the temperature in the diagram, which we'll be finding on the x-axis, so the horizontal axis as indicated by the red arrow here. The further we go to the right-hand side, the higher the temperature is. And then next to the temperature, we have the pressure, the air pressure, which we can find on the left-hand side of the diagram on the y-axis. The higher we go on the y-axis, the lower the pressure is. As you can see, the steps on the x-axis, the horizontal axis of the temperature, are equal. But on the y-axis, the steps between the pressure levels, so going from 500 to 400 and from 400 to 300, they are not equal in size. It is a logarithmic scale. That's also why the name skew-T log-P has the part log-P in there. Then there's still the other part of the name, skew-T. The T, of course, stands for temperature, but the word skew stands for the fact that the lines of equal temperature are not exactly going vertical. They are skewed. I have indicated those skewed lines with the red lines in the diagram here. So the -20, -10, 0 and 10 degree lines in this case. They are skewing to the right. And there's a reason for this. Because the higher we go in the atmosphere, the colder it gets. If we want to show the state of the atmosphere for the first, let's say, 15 kilometers height, it gets very cold above. And that means that the temperature has to go from way down on the right-hand side to way up on the left-hand side. But that makes a very big diagram. We want to keep the diagram a bit smaller and a bit easier to understand. That's why we are skewing the lines of equal temperature so it just better fits in the diagram. So let's do a little exercise together. I've added an example to find the temperature of a parcel at 500 hectopascals, which is approximately 5.5 kilometers height. As you can see, the black circle here is the parcel. And now I want to know which temperature that parcel has. If I just look vertical, it would be between 10 and 20 degrees below zero, so -10, -20. But we know the temperature lines are skewed, so this is of course not the case. Conveniently, I have added the parcel on one of the red lines that are showing the exact value for a temperature. So let's follow that line back down to 1000 hectopascals. This way, we end up at the -40 level. So the temperature of this parcel is -40. Having discussed the temperature and the pressure now, let's continue with the other lines. And one of them stands for the water vapor mixing ratio. This is the amount of water vapor, the amount of grams of water vapor per kilogram of air. The more moist your air is, of course, the higher this value is. In the diagram, we can recognize these lines with the purplish dotted lines, but I will highlight them here with the purple lines that are continuous. Now, mind you, the angle of these lines is slightly different from the ones of the temperature, and thus it's important to recognize their difference. In most skew-T diagrams, it is not too difficult to recognize these lines. In most cases, they will be shown as dotted lines, or, for example, the temperature line is more thick or has a different color. But the difference in their angle is important to recognize. Then, of course, there's much more in a diagram. Two lines that are not shown yet here are also important, and they are two basic lines that describe the state of the atmosphere going all the way up into, well, let's say 12 to 15 kilometers height. They are lines that show the temperature of the air at a certain height, and then there's another line that shows the dew point temperature. So in this diagram, I've added a real case from the internet back in 2018. In this example, you can see two black lines. The line on the right-hand side shows the temperature. The line on the left-hand side shows the dew point temperature. The temperature is, of course, easy to understand. It is just the temperature of the air going up with height. The dew point temperature is a term that needs a little bit more explanation. Now, the dew point temperature is the temperature at which an air parcel would become saturated if it cooled down. Mind you, this would only be valid if it stays at the same height, so not if we rise the parcel. But let's think of a certain day, it is warm, and then we go into the evening and night and the air cools down. If the air is able to cool down to the value of the dew point temperature, we get saturated air. Maybe we can get a bit of fog, but most likely that's when you can see dew on the vegetation. Of course, that's why the name is dew point temperature. It's the point where air reaches saturation and where we could expect dew to happen. All right, so knowing these things, the next step is to talk about other lines that we haven't spoken of yet. And they are important to be able to follow a parcel if it should rise. And there's two important lines in the diagram, the dry adiabat and the moist adiabat lines. So let's begin with the dry adiabat line. I have highlighted here with the green line, the line for the dry adiabat. This is the evolution of the temperature if a parcel would rise while it is dry, so there's no condensation yet. As you can see, it goes to the left. So let's say we indeed begin at 1000 hectopascals with a parcel that has a temperature of 20 degrees, we would follow exactly this line. The second important line is the moist adiabat, and this tells us something about the evolution of the temperature of a rising air parcel if we had condensation. So if the air parcel is already saturated. There's a big difference between those lines. The moist adiabat, I have shown it here with the blue line. And as you can see, their angle is much different. The reason why is because when an air parcel reaches saturation and we get condensation, that means that the water vapor goes from a gas to a liquid, and that releases heat. So if the air parcel rises, still it's cooling down, but because there's also some heat release, it is cooling down less quickly than it would if it were dry. So let's do a short exercise here. And let's take a parcel and start rising it following the skew-T diagram. All right, so in this case, I have taken an air parcel at 1000 hectopascals, and let's call that the surface for now, with a temperature of 20 degrees. In this case, we start following the dry adiabatic line because it's not yet saturated. That's the green line in this case. But at a certain point, we reach saturation. So we need to switch from the dry adiabatic line to the moist adiabatic line, which would be the blue line here. So if in the end we start following the parcel, we go up at first following the green line, but in this case at about 800 hectopascals, we switch to the moist adiabatic line because we assume in this case it reaches saturation. Then we follow the parcel going up even further, but using the blue line. And we continue using this because as the parcel rises, it keeps on giving condensation in this case. So that's how to follow a rising parcel using a skew-T diagram and using the lines we discussed before. So that concludes this video, the first video about a skew-T. To summarize, we've discussed the skew-T diagram, its official name, skew-T log P diagram. And it's an important diagram to analyze the vertical structure of the atmosphere. It contained many lines, and we discussed them. And each of them has their own important purpose, so we need to remember that. And it can be used to follow rising parcels and analyze if and when they can condensate. Finally, we can use the skew-T diagrams and apply them to wildfires. Now that's something for the next videos, so I hope to see you there, and we'll continue working on understanding and using skew-T diagrams.